Okay, welcome back. Now we are going to start making our front end. The reason why the front end is split up into a different video is because what you choose to put on the front of your robot can dictate a lot of stuff on how well it's going to fare against other robots. To demonstrate this, I'm going to pull up MS Paint. Ooh, you're going to see a lot of really bad drawing by me today. But I'm going to show you like a little, kind of like a rock, paper, scissors chart, but for forks, wedges, horizontal spinners, and vertical spinners. So let's go draw that right now. We're going to see how badly I can draw stuff. So, okay. This is wedges. Verts. Okay, so typically, when you run, let's say, a vertical spinner, a lot of people just typically only run forks with them. This is for a couple reasons. When you have the forks, it helps you control the opponent, but also they're really good at getting under wedges. So, forks beat wedges. Boom. So I'm going to draw an arrow indicating that. Now, what are the wedges good for? The wedges are good for deflecting damage, not from a vertical spinner because that would hit them upwards, but for sideways hitting damage. So if you can imagine a wedge, right? Like at an angle like this, horizontal spinner came at them like this. This is like the bar of a horizontal spinner, if you can imagine that. This spinning bar will get deflected by this wedge. So the wedge is really good against horizontals. There we go. So, but a horizontal spinner, if you can imagine that horizontal spinning bar again, do you know what is good against hitting? Forks, because they're dinky little, they're just little forks. That's all they are. They're pretty small, relatively thin, only mounted by like two little things on either side. The horizontal will smack the forks out of the way, so the horizontal is really good against forks. You can see the vert is kind of kicked out of this triangle here, and I'll explain why. It's because the verts can run wedges or forks. Horizontals, people usually don't run either, not wedge nor forks. But a vert can put a lot of stuff in that front end, you know? Let's say if you're running a vert with forks, you can be really good at beating robots with wedges on them, or other verts. If you're running a vert with a wedge, you can be really good at beating horizontals. So I like verts because it gives you that added layer of creativity to the weapon, because the weapon would be like in the front of the robot like this. You can imagine that's the vert. You can put whatever you want here. For example, you can put forks, or you can put a big wedge. So it's pretty versatile. I'm gonna go over making a fixed front end. I don't know how much time it's gonna take to go over making a modular front end for the robot. But that is something I will go over in the future. But for this, just the basics, we're gonna go over a fixed front end. And the front end will look something like, hold on. Okay, not exactly like this, but kind of a mix of both. If I were to run a fixed front end setup, where I can't replace it, I would run a mix of both with tiny forks in the front and then wedges that span out to the sides. And that's what I'm going to show how to do. So, to go over that again, horizontals beat forks, forks beat wedges, wedges beat horizontals. Verts are good is because since there's so much open space on the front of the robot, also where the weapon is, you can put forks on there too, and you can also put wedges on there. So it's like a kind of a modular thing, and you can choose what you want to do. Little side tip though, if you're designing a horizontal, what some people are doing nowadays, and what I encourage more people who make horizontal spinners should do, is throw wedges on the back, throw forks on the back. Who's saying you can't put front end on your horizontal? Just put it on the back. So yeah, I'm gonna go over that when we make a horizontal later in this video class, but that's at a later time. So let's go make this vertical spinner. Okay, so let's start with the little wedge piece. In order to do that, let's head back to the parts studio because that's where we actually edit everything. And then we're going to make a sketch on the side of this chassis. So we're going to click sketch, click the side here, and you see it pulls this up. So now, with this as a reference, we can start drawing out our wedge. So what should the wedge look like? I'm thinking it should stick out maybe 2 inches. Click and press 2. Actually a little bit less. When I make my wedges, I don't like them sticking out too far. I like having the weapon stick out a little further. That's a little bit subjective. It's kind of up to you. I like having my weapon stick out more. It kind of guarantees I have a better impact when I hit the opponent, and I don't have to rely on getting the opponent over my wedge before I can hit them with the weapon. When I have the weapon sticking out more, it gives me a better chance of actually hitting them. So I'm gonna have my wedge only stick out, yeah, maybe 1.5 inches. Actually, even less. 1.25. Maybe less? No, 1.25 is good. Okay, now that I have that, I'm just gonna kind of complete the triangle just so I have a rough idea of what the wedge would look like. Yeah, I'm not really liking that, so we're gonna go adjust that a little bit. For this portion, it's partly by feel and partly by experience. All of the stuff that is more experience-wise, I'm gonna go over and explain to you exactly why I'm doing it. All the stuff that isn't really experience, and I don't really explain, I'm not really explaining what I'm doing, is because you can do it. Go ahead, have a little fun. It is your robot after all. So, I am making this wedge a little bit higher than the actual chassis itself. There is an actual reason for that. It's because I don't want a horizontal spinner. Let's say a horizontal spinner comes and hit this weapon or hit the wedge. If the horizontal spinner hits the wedge, there's a chance it could go up the wedge, right up the wedge, and then go to the top plate. I don't want that, so I'm gonna make sure my wedge sticks up just ever so slightly so it doesn't ride up to the top of my robot. I think that this is a decent enough shape. 0.3 inches at an angle that I don't remember, and then 1¼ inches out. So now that we have that, Shift E for extrude. I want it going this way, and then I want it to reach this end. I did it wrong. Hold on. I want it to go that far. That's 2 inches. Hit the check. There we go. That's kind of a wedge thingy. Although I do believe that's a different part. I want that to be the same part. Merge scope. Click part 1. There we go. That's the start of our little wedge. Go back to the assembly so you can really see how the wedge would interact. Now that I'm seeing this, I think actually I can make the wedge stick out just a little bit farther. So we can go back to edit sketch 16. And then I want to change this 1.25 to 1.5. Let's see how that changed the angle here. Did that even change? Oh, there it is. I take it back. I think I'm thinking somewhere in the middle. So 1.35. Enter. That's better. Okay, now that we have that, let's go mirror that on the other side. Back part Studio 1. Yes, this is good. And then let's go mirror this. So mirror, entities to mirror. We can just click the whole body, mirror plane, click the right one. There we go. This is pretty close to done already. You can see this video won't be too long. Well, at least won't be the hour-long video that the last one was. So yeah, now that we have some wedges, this looks pretty cool. We're gonna add some tiny forks now. Okay, so for the forks, there's two different forks you can make. Fish whoa, what am I, fixed forks, which are forks that are fixed in place, they can't move, or forks that can pivot, so like movable forks. Forks that can pivot are good because let's say a robot gets tilted up a little bit. Let's say my robot on an impact gets tilted like this, or I'm tilted forward like this. My forks will still be touching the ground because gravity keeps them pushing down. If the forks were fixed at an angle and my robot gets tilted like this, my forks will start pointing up because they're fixed in that position. That being said, fixed forks aren't always horrible. For two-wheel drive robots, you can ensure that one of the places that your robot is driving on is your forks. Because obviously, with a robot like this, it's not going to balance perfectly like this. It's going to be at a bit of an angle when it's actually on the floor, right? If you can imagine that. It would touch, oops, kind of like this. I can't get the angle perfect, but okay. It would touch here on the wheels, and then it would touch right here on the edge of this wedge. What you want it to be touching is on the forks, because you want your forks to be scraping the ground almost all the time, pretty much. So fixed forks aren't always bad. For two-wheel drive robots, you can make sure that it balances on your forks. That's how you ensure your forks always stay low to the ground. So we're going to make fixed forks for this robot. And for these forks, we're going to have them mounted onto the uprights. So we're going to find where the uprights are. Extrude 2. Okay. We're going to go edit the the sketch that your uprights are made on. And we're going to modify this so we can put some forks. So where should we start? I'm thinking forks should go down like this and then go out obviously farther than the wedges, so maybe 2 inches. 1.75 actually. 2 inches is a little much. I like my forks, at least for this robot specifically, I don't want them to stick out too much because in plastic ant weights, the forks can snap pretty easily. So I don't like having forks. When I do run forks, they're either really thick or don't stick out too far to make sure they don't get really damaged. For this robot, I just don't want them to stick out too far because I don't think I have enough room to make them thick enough. 1.6. And then from here, I'm going to add the fork angle. I'm going to do the angle by eye. I'm thinking actually, I need to figure out where it stops first. I'm thinking right here in the middle of this 1.6. And then 1.15 going up from the center. Click here, you can see how that makes a triangle. I think that looks fine for the forks. So with that being done, we can add a T-point arc. Just go here, connect it here, click the check. Boom. That is our little fork. So let's go extrude it. Hit the check. There we go. Now you can see how that adds little forks, and we can make those a little longer. I think I didn't do enough. So 1.6, we're gonna do maybe 2 is fine. And then I'm thinking that these forks are way too thin right now. So I'm gonna change this actually to 1.8. And then change this. Oh, stuff moved. Delete this. There we go. Now it changes to 1.8. So now we have this. This is pretty much almost done. Doesn't that look cool? That looks pretty dope if I do say so myself. We're gonna add a few final touches. Oh, interesting how this didn't copy over. Weird. Oh, because this is a different part. Make sure when you do your mirror, you set add instead of new. Merge scope, connect it with this. There we go. There we go. Alright, we're going to add a couple more things. First of all, these wheels are pretty exposed. I'm going to make sure they don't get clipped as easily. And in order to do that, we're gonna head back to Part Studio 1, and we're gonna go back to this sketch 16. We're gonna make some wheel guards. Not wheel guards that go all the way around the wheel. I find that casing the wheel entirely, that's fine, but it can cause some other issues, just like, let's say, with maintenance. They often get snapped off pretty easily. I like having wheel guards to protect just the front of the wheel. So if you can imagine from a top view, kind of like a triangle like this. Why do I not protect the entire wheel? I noticed that when I protect the entire wheel, this side part gets broken a lot, and I have to replace it a lot. It's often just extra spots for horizontals to hit instead of actually protecting anything. For me, this is totally personal. Let's say if you're not so great at driving or you're just new, I recommend encasing your entire wheel. But I am not too bad at driving, I would say. I'm pretty good at keeping the fronts of my robot facing the opponent, so I don't protect my wheels too much. But that's all personal. If you want to protect your wheels, go ahead and design that. But I'm going to design some front wheel guards. So to start, I'm going to make some lines sticking out 2.25 inches on either side, which is also this midpoint. And then from there, I'm going to use the 3-point arc tool, go from the top to bottom, and then make a little arc, kind of like this. Oops, forgot to mention it. 0.8. There we go. And then from there, we can extrude this whole thing. So we're gonna just select this little rectangle. The part that we traced out, Shift E for extrude, and then there we go. Now you can kind of see what we're doing here. Drag this out. I'm thinking 1.2. No, just 1 inch. Yeah, that's good. Now, this is just a box right now, but we're gonna go modify it. Okay, I'm thinking we're gonna add a sketch on the top, and then we're just gonna kind of trim it out, kind of like negative space, like we're carving. So I'm gonna add a line which is cutting this rectangle in half, and then I'm gonna use Shift E for extrude. We're gonna use Shift E to click remove, and then we're gonna remove all of that. So hit the check. There we go. Now we just copy this over again. Mirror, click the whole thing, make sure it's add instead of new. Mirror plane, hit the right plane, merge scope, click the chassis, hit the check. There we go. That is our armor in our front end. I'm gonna smooth it out a little bit with some fillets and stuff. Okay, so I just added a couple fillets here and here, and then I added some in the back as well. This is looking pretty good. So we're almost done, but it is missing a few things that are pretty important for a robot. One of which is a top plate, and the other are mounting screws. So we're gonna go over that right now. Let's go add stuff to this robot so we can actually mount things to it. Let's start off with the screws that will mount into the weapon motor. As you can see here, there's nothing to actually hold this weapon motor on, but if we go to the weapon motor CAD, we can see 4 screw holes that we need to make holes for. Also, this little sensor needs a hole because the silver part actually spins, and we don't want it interfering. So we're gonna make a little hole here too. Let's go to the CAD. Let's hit a sketch, and then let's go click this face right here because that's where the holes will be. Zoom in, and then we're gonna project this. Oh, actually, we don't need to project this because this should already pop up. Yeah, if you highlight around the middle of this circle, there should be like an invisible dot here. You can click it, and you can make a circle. We're gonna make it let's say 0.25 inches big. Actually, 0.2. Okay, good. Now, to know where the rest of the circles are going to go for the mounting, let's go look at this CAD. As you can see here, we can see the 4 holes, and we can measure exactly how far they are. So, let's do that. Let's imagine if we take a line, oops, click sketch, click this face, and we can use a line tool to actually measure the whole distance of everything. For example, from the center to this hole, I'll have to project to this, actually. Wait, do I? So from the center to this hole is 0.315 inches. So I know over here, I can make a line that goes 0.315 inches, and then I know there's going to be a hole over here. Oops, wrong tab. So we can go back, and we can check it for all of the other sides. First, let's project these circles so I can actually see them. There we go. This one is also 0.315. This is 0.374. This one is also 0.374. So up and down, we're going to use 0.374, 0.374, 0.374, and then left and right, we're going to use 0.315. 0.315. Good. Now we can just add the holes. They can be like 3 millimeters. It's good. So type 3 mm, or 0.118 if you want to use imperial. There. Now we should have 4 holes like this. Looking back on this hole could actually be larger. Never mind. 0.25. Okay. Now we can extrude all of these. Change it to remove because we want to remove stuff. And then, yeah, looks good. Okay. So now we have that. Perfect. A few more things need holes though. For example, the top plates will need some holes. It also doesn't even have a top plate, so we're gonna have to add that after as well. And then these uprights will also need holes. So let's start with the top plate holes, or soon to be top plate holes. So let's click the top of the robot, get a top view, and then we're gonna go zoom in right here. You see these 4 corners? Well, we can't use these 4 corners because they are being occupied by the motor mounts. So we're gonna use the center instead. Click with a circle, and then we're gonna drag it out to the edge of the wall. I should make ½ inch circle in the back. Over here, these circles will be, oh yeah, also ½ inch. Perfect. And then we can extrude those going down. Hit the check. Perfect. Now these will be the little spots where we can add our mounting. Now for this robot, we are going to use something called heat set inserts. They look like this. There's something you heat them up with a soldering iron or something else hot, and you push them in. If you don't have access to a soldering iron or something, you can use plastic screws, which are screws that form themselves into the plastic. I don't recommend them because after a while, those screws tend to just chew up the plastic, and in the long run, they don't hold. I like the heat set inserts because it has a nice brass threads for the screws to tap into. They seem to hold better for me, although, I mean, if you don't have soldering iron or something hot like that, what are you gonna do? Now, these heat set inserts are about 5 millimeters in width. About 5 millimeters. So, we're gonna head to our CAD, go back to the sketch 19, and then we're gonna make holes here that are 4.5 millimeters. Now, why not 5 millimeters? We're not doing 5 millimeters because we need the grooves here to actually lock into something. It's nice to spec the holes a tiny bit smaller because it allows the heat set insert to really grab into the side of the wall. So instead of 5 millimeters, like the CAD says, we're going to do 4.5. Now that we have all 3 holes, we're going to press Shift E, and then we're going to select the holes that we made. Oops, what did I select? We're going to select all of these holes, and then we're going to press Shift E. There we go. From here, we can press Remove. And then, we're going to carve out how much material. How much material are we going to carve out? Well, if we go to the CAD, we can see it's about 4 millimeters deep. But we also have to consider that the screw might go in a little more. So, let's give it, let's say 6 millimeters. Good. Now, as you can see, if we had this sketch, there's 2 different heights in there, so we're going to fix that with another extrude. Okay, so now they're the same height. I have a little artifact line. We're going to ignore that. I had to extrude them 0.474 inches upward. Now we have top plate screws. There's one more thing we need to add now, and that is screws for the bottom of these uprights. For the upright screws, we're going to start by hiding the chassis. So part 1, we're going to hide it. And then we're going to make holes. Let's go click the sketch, and let's click the bottom plane. Or I guess top plane, but we're going to click top plane. And then we're going to project, or U, all of these lines here. There we go. So now we have a bunch of lines of the uprights that we can use. So we're going to make one big line through the center of each upright, and these will be our guidelines. So we can change them to construction lines. Okay. Now we gotta just put some screw holes. So I'm thinking we're gonna have 3 screw holes per upright. That sounds fine. Let's go to the midpoint of this upright, and then it's the same process. So, what was the size? 4.5 millimeters. Good. Now we're just gonna need to add more. So I'm thinking what looks about right. 0.45. 0.45 inches up from the center. I'm thinking another screw would be good over there. And then we just repeat the same thing going down. Now that that's done, we can extrude these. Okay, sorry, I had a little struggle selecting the holes that I wanted to actually extrude, but now that I have them selected, we're gonna click remove. And then we're going to drag it up, let's say 0.75 inches. Merge scope. For merge scope, we want it to merge with just these 2 parts. Actually, I lied. We're going to have it merge with part 1 as well. And I'll show you why. Now let's click the check. And there we go. The reason why we had to go through everything is because it makes holes for everything. One extrude does the pathing for both these holes, therefore we have a path for the screws to go, along with a place for the inserts to go. Now from here, let's go make our top plate. Now the top plate will be easy. If we click a sketch on the top, and then from the top sketch, all we are going to do is outline the top. Just trace it out, everything. I saved these little curved bits for last. You can also press project and project them as well. That's good if you have like really funky lines with your CAD. Something else we also want to keep are these screw holes. Okay, now that we have that, let's go press Shift E. Oops, I made a revolve as well. Let's delete the revolve. Go to this, press Shift E. There we go. Now you can see where our top plate's gonna kind of pop out. But obviously you don't want to be an inch. I'm thinking 1/8 inch. How's that? Hit the check. That's perfect. So 0.125 or 1/8 inches. There we have it. This is looking like a pretty complete robot. Now this is looking pretty complete. There's a couple things I want to adjust. For example, this upright here isn't really doing anything. I'm probably going to move this all inward, so you can imagine this upright can support this other arm of the motor. But besides that, this is looking pretty complete. If you've made it this far and didn't customize it at all, you kind of focused on exactly what I was doing, I recommend you just kind of go crazy with it. This is pretty much the end of what I have to show you for the vertical spinner. It's not completely done yet, obviously. Like I said, I have to move this inward. There's a couple other things that I didn't add, and that was on purpose. For example, this robot needs a hole for the power switch and the safety light. The safety light I could have added, to be honest, but some people want their safety light in some different place. For the power switch, however, there's a lot of different ways people power on the robot. They have their finger tech switch, which is like that little screw switch, so you need a hole on the top of the robot. I know some Viper kits come with that little plug-in switch where it has that little like audio cable, and you plug it in and you take it off to start the robot. Depending on what style of switch you have, the hole might be in different places, but I trust you guys that you can put a hole in the CAD to show exactly where your robot will turn on and off, as long as you follow this tutorial. I think you guys will be well versed enough in CAD to be able to do those things. So I encourage you to kind of go crazy with the CAD, mess around with it, because we are officially complete. Congratulations. Come back in the next video and we are going to show you how to make a horizontal spinner. Horizontal spinners are awesome because while they are a little bit tricky to drive, they pack a real serious punch, and that is what a lot of people love to see off of the sport. And I'm going to show you how to make a horizontal spinner that packs the most punch, and also a horizontal spinner that kind of flips the script. A horizontal spinner that can drive really well, doesn't hit super hard, but you can be very precise with a horizontal spinner. And that is something not a lot of people do, and I will show you how to do it in the next series of videos. So come back and I will show you exactly how to do that. Thank you so much for watching, and goodbye!